6.1 you say is easy.
Because 6.1 was one of the examples you gave us, ma'am. Yeah, the propene, because we did that one together before.
So 6.1 we don't have to do.
Yes, ma'am.
Okay.
It's 6.2.
So it's 6.2.
Yes.
The formula for 6.2 is C3H4. You know why you couldn't do this one? Is because we haven't discussed the alkynes yet.
Yes.
Ma'am, could you use the general formula for each of the ones to determine what they are?
Yes, that is what we do. We have not yet discussed the alkynes. We have started discussing the alkenes, and we have discussed the alkanes. So the general formula for the alkanes is CnH2n plus 2. I'll come back. Next one. Just give me a chance so that I will. So ethane is CC with each carbon having 3 hydrogens joined to it. So you can see 2 times 2 plus 2 will give you.
Your space of minus. How many?
I haven't been recording. So let's just go over it again. The alkanes we've done, they're saturated hydrocarbons. Each carbon, there's only single bonds between carbon atoms, and each carbon must have 4 bonds. So ethane looks like this. And we've already discovered or deduced the general formula, CnH2n plus 2. Okay. To go from the ethane to the ethene, which is an alkene, a double bond forms between the 2 carbon atoms. So now each carbon can only form bonds with 2 hydrogen atoms. So how many less hydrogen atoms do we have? 2 less. So it's CnH2n plus 2 minus 2. So that's where the plus 2 disappeared. To go from the ethene to the ethane, where there's a triple bond between the carbon atoms, we have only carbon with 1 hydrogen, carbon with 1 hydrogen. So we subtract another 2 hydrogens from the general formula.
I don't think you have to. We just wanted to come back to physics.
So we don't miss another.
So could you say every time it loses 2 protons?
No, 2 hydrogen atoms, because they go with their electrons. They don't leave their electrons there. So it's like less hydrogen atoms. A proton is a hydrogen ion, meaning that the atom left its electron there, which didn't have to happen. Okay, so this one follows the rule for alkenes, am I right?
Yes.
C,
Yes.
N
Yes.
is 3, H, this is 3, 3 times 2 is 6, minus 2 is 4. So this one follows, so this is an alkyne. How many carbons are there in this alkyne? So there are 3 carbons in the alkyne. It's an alkyne, so there must be 1 carbon with 3 bonds. So this carbon can take 1 more bond. Am I right? Takes it with the hydrogen. Can this carbon take another bond? No, it's got 4 bonds already. How many bonds can this carbon take? 3. So this is the structural formula for propine. It would have been propane if it was only single bonds between them. Okay, so propine's molecular formula. What would the condensed structural formula be? CH triple bond C CH3.
No? So there's a 3 carbon make it propane, and then because it's alkaline, it's propane.
The names match the category. Come on.
This is propine because it's an alkyne.
Yeah. Okay, but is the reason because it's propane instead of propane? The CCCs.
There are three carbons make it prop.
Yes.
Triple bond between 2 carbons make it ine. Yes. Alright, please AJ. Number 7, was there a problem there? Because that's where we ended before we could get there in our last lesson.
That is just how many different positions.
It's fine, we'll get to that.
Then with the EP is the condensed formula.
CH2 double bond CH2. Must I do number 7?
Yes, please.
Yes, because that was where we ended. Before we could do this, we ended before we could do this. So the molecular formula or the structural formula is C with 3 hydrogens. Am I right with that? Then there is a single bond with another C, a double bond with the next C, and a single bond with the 4th C. So this one takes 1 more hydrogen, this one takes 1 more hydrogen. Each carbon has 4 bonds now. What is this molecule's basic name? Butene. Where is the double bond? Between carbon 2 and 3. So this is 2-butene, or you could write it but-2-ene. 2 ways of writing it.
Why is it
Okay.
Because it's in between it.
Because the ene refers to the double bond,
Oh,
and the 2 refers to the position of the double bond. I prefer this way, but you need to know both ways. Because if but-2-ene is given to you, you need to understand it's 2-butene. Okay. How many different positions are there for the double bond? The one we had on the screen yesterday was this one. This is where we ended the lesson yesterday.
Yeah, the protein.
What is this?
Protein.
No ways.
It's
It's still butene.
But now it's just
one
butene.
Yes, you indicate with a 1-butene, you indicate the position of the double bond. Because the position of the double bond is between the first and the second carbon. So the lowest numbered chain, the lowest numbered carbon atom, double and triple bonds takes preference. So that double bond is between the first and second carbon. This double bond is between the second and third carbon.
And they can only have 2
So, ma'am,
positions because if you did
The
it
double bonds can only have 2
if you did it
positions.
the other way around, you have to count them around.
Yes, you're right. You're right.
What does it mean by takes preference?
I'll explain to you later when we get to another
So you
example.
can't have a double bond by like between C3 and C4 because it's not the lowest.
Yes, then you number from that side.
Okay, you just
If
change
the double bond was here,
It's
then it's 1, 2. Then it's the same as the You see, whether you look at the molecule from your side or from my side, I have to count from my right to the left, and you're counting from left to right. Whether you're looking at the molecule from this side or from this side, it doesn't matter. It doesn't change the molecule, because now you just count from this side.
So it can't be between 3 and 4.
No.
Yes, if you say that, you get it wrong.
Yes. Okay. All right. Sorry. We are on the isomers of butene. We must be able to write the condensed structural formula.
When would this be a position isomer or chain?
These two are positional isomers, because the chain length is 4 carbons in each, but the position of the double bond is
So
different.
position,
So these ones are positional.
so basically position depends on the number of bonds one atom. Like a specific atom can form, like if it's a double bond, triple bond.
No, positional isomers have the functional group or the active part in different positions.
So it's a chain of
The
swing.
chain, I'll give you a chain isomer now, just hold on. So this one's got 4 carbons in the chain, this one's got 4 carbons in the chain, but the double bond is in the different position, so they are positional isomers.
With the 2-butene and the 1-butene, does it change their characteristics in terms of boiling point and melting point?
Slightly, yes.
Because the structure of it is different.
Yeah. You see, the reactive part of the molecule is the double bond part. So it's going to change the chemical reactions of the molecules. I don't think there will be much change in boiling point. If it's change in boiling point, it will be very small.
Will be close, but
Okay.
not the same.
This one is the only positional isomer for 1-butene. But we can do the following. Take one of the carbons from the longest chain and put it there.
Is that a chain?
I didn't change the position of the double bond, but we changed the length of the longest chain. So these two are chain isomers. Because now the molecular formula is still C4H8. Am I right?
Yes,
C4H8 is the molecular isomer, is the molecular formula. Yes?
Yes, yes,
Ma'am,
The second.
you said it's still C4. How's it going to be C4 if we count like this?
The number of carbon atoms in the molecule is still 4.
Ma'am,
The number of hydrogen atoms is still 8.
ma'am, isn't it going to be C3?
No, it is the longest chain has 3 carbons. 1, 2, 3. Now this is the meaning of the number of carbon. Double and triple bonds take preference. You see, we could count from this side 1, 2, 3, and your methyl group will be on the second carbon. But the double bond then will also be between the second and third carbon. Can't be like that. You've got to count the carbon atoms in the longest chain so that the double bond would be on the lowest numbered carbon. So we have to count from that side. We can count around the corner though. We can make that carbon number 3. We're allowed to count around corners. Tina. You? Yeah? Marcus.
Can you please explain again why we can't count from the outside?
Because then the double bond is on the second carbon and not on the first carbon. So your double bond takes preference. You must count from the side where the double bond will be on the lowest numbered carbon. Yeah, it doesn't matter.
So what it means by take preference means count on the side of the disc.
Count from the side where the double bond is. Okay. So this is propene.
Yes.
This is a propene.
You can also put the 3 by the other one.
I know, I did. This is propene. And it is 1 propene.
So, ma'am, do not take the methyl which contains.
I'm getting there. First, start with the last part of the name. And methyl.
While we're waiting for Uko, can you please explain why you said
Oh, yeah.
we put the ENE?
ENE is for alkenes,
So alkanes is
where there's a double bond between 2 carbon atoms. Alkanes are saturated, only single bonds between carbons. Alkenes have double bonds,
an alkyne.
have triple bonds.
That's just the 3.
Yeah.
So alkanes are the only saturated ones in the whole.
No.
In the hydrocarbons, the alkanes are the only saturated ones. Alkenes and alkynes are unsaturated. It means that the double or the triple bonds can break to add more atoms to the molecules. Okay. So after this, I'm going to roll faster. We're going to do the other homologous series as well. So the isomers of pentene. Pentene is an alkene. It's an alkene. And it refers to the double bond between 2 carbon atoms being present. It's an unsaturated hydrocarbon. It means that the double bond can break and 2 more atoms can link up to 2 carbon atoms. We'll still do the reactions of these molecules. What is the general formula for the alkenes? So this one's formula is C5H10. Okay. Now take some time and write down the straight chain molecule.
So can you use pentene for freezers? Because we were buying a freezer with this ice cream and it said C5H10.
Okay, then it's most probably the cooling agent.
But then how do you know where the double bond is?
You put it the first position and then we're going to move it on. Right, so just start, grade 12, just start with the double bond between the first 2 carbons. Be careful here. A carbon atom can only form 4 bonds. So there mustn't be more or less bonds on a carbon.
So a double bond or triple bond means unsaturated.
Yes.
We can break up.
Mm. So this one is what? 1 pentene. Okay. Yes.
And you see, ma'am, after the double bond, why doesn't that start have a H?
Because it's got those two bonds with that carbon, and it's got this bond already. So it's got only 3 bonds. It needs another bond to have 4 bonds. That's why that one takes 1 carbon. So this one's condensed structural formula is CH2 double bond CH. Then we could shorten it CH2 twice, okay, and CH3.
Is that the condensed formula?
Yes.
So ma'am, if you did it
Condensed
like CH3,
structure.
put in brackets and put like a 4 outside, because 4 of them are like, they have CH2.
Not 4.
Oh no.
There's 2 CH2s.
Oh, okay.
It's this one and that one.
Oh, okay.
So this is there. This one is that one. These 2 are there. And this one is there. Okay. Now don't change the position of the double bond. Change it to a chain isomer.
Okay. Easy.
Don't move the double bond. Make chain isomers. See how many chain isomers you can get out of it. So just to make sure, we cut the carbon off the pentene, and we made it a methyl group here on the second carbon. Okay, so it's 2-methyl 1-butene. Right? Now, from here, I want you to go to a positional isomer. Not a chain isomer, so it still needs 4 carbons in the longest chain. Yes.
So I just move a double bond 1 forward.
No, you leave the double bond where it is.
Double bond is
I don't want the double bond to be moved. I want the methyl group to be moved.
So I'm going to just move it to the third.
Move the chain isomer.
Exactly.
And then it would be 3 methyl and 1 butane.
So I wanted you not to move the double bond. I want you to move the methyl group.
Didn't you just say you wanted us to move it to
Oh,
In that is a position isomer.
So you can move it one.
I don't want you to move the double bond yet. There are more positional isomers for this molecule, but I wanted you to see that you can move the methyl group. So this one, I can't count from the right hand side because the double bond is on the left hand side. So I've got to count from the side where the double bond is, and now I can go straight or around the corner. I'm going to go straight. Going straight or around the corner won't change anything.
What are you asking us to do now?
Move the carbon.
Which carbon?
Move the
The
methyl
methyl
group.
one.
The third carbon.
yeah.
So it is 3 methyl 1 butene. Mm.
I don't know. Please explain the position of isomers.
The position of this thing is not on the second carbon anymore. It is on the third carbon now. So the functional group changed position in the chain. So they are positional isomers. They are isomers because all these molecules have the same molecular formula, C5H10. But because there are many possibilities for the chain length, as well as the position for the double bond and the methyl group's positions, they form isomers with different properties. Yes.
Ma'am, the third carbon, if you move that and the one under it, under the 2, would it be 2 ethyl, 1 butene?
Okay,
Or,
let's do it. No, let's do it. Let's see. You draw it out so long while we are busy with it, and then we'll see what it will look like. Can I move? So, Marcus is suggesting this. C double bond C, and then
Under it.
under it,
Two
yeah.
carbons under it.
2 carbons under it.
Yes.
Like this.
Yes, and then 1 forward.
And then 1 forward.
Yes.
Okay, wait, be patient. Let's just make sure that each carbon has 4 bonds. This one's got 4 bonds.
Yes.
This one needs 4 bonds. So I need 3 more hydrogens here. And this one needs 2 more bonds. This one needs... Wait, you're in a rush. Remember, we can count around corners. So where are we going to count now? 1, 2, 3, 4. So this is still 2 methyl, 1 butene.
Does the second carbon have 4 bonds? And how is it? Where's the fourth one?
This is 1 bond, that is 2 bonds, this is 3 bonds, that is 4 bonds.
I don't get the outcome of the people. Can you add another carbon on the side?
But then it's not the same molecule.
Yeah, I know.
Okay.
Ma'am, before you
So-
remove that, can I ask, ma'am, how's that the same when there's added on
Carbon going downwards. Wouldn't that then be 2 in the middle there instead of 1?
Ma'am, there'd be another position.
This molecule here is the same as this molecule here.
It's just around the corner now.
It's just you put it on in a funny way on paper. That's all.
Would that other one be another positional isomer?
No, wait now. Let's just get the other one. This one.
Yeah, this one.
This one is the same as this one.
So it's not even a position.
It's a chain isomer of the original molecule, and it's a positional isomer of that 3-methyl 1-butene.
Yeah, okay.
So you didn't get the
Outcome I was looking
effect
for.
that you were looking for. So now
I needed another carbon.
let's go. You need a bigger molecule. You see, the bigger the molecule, the more possibilities for isomerism there is. So let's go for that one because you wanted it. But it's not an isomer of
It would be a completely own.
pentene. So you want it to look like this.
Yes, and then 2 down.
you guys do a straight line?
So that would be 2.
So this
1 butene.
This is an isomer of which molecule? What is the molecular formula?
C.
What is the molecular formula?
C6H12.
So it's hexene.
C6H12
Yes, no.
is then
Hexene.
hexene. Okay, so it is a chain isomer of one hexene.
Yes.
Am I right?
Yes.
Okay.
What do we
Now,
call this molecule?
It's going
Two ethene, one butene.
now the longest chain here, please, I'm using this example to reinforce the rules there. The longest chain has 1, 2, 3, 4, 5 carbon atoms. But that longest chain doesn't contain the double bond.
So you
The
don't use
double
it.
bond must be part of the longest chain.
It takes preference.
And it takes preference, so you have to count from the side of the double bond.
Oh yes.
Can't we change the position of the double bond?
Not now. You can, but not now. So 1, 2, 3, 4. Doesn't matter whether you count straight across or whether you go at an angle down. There are 4 carbons in the longest chain that's got the double bond in. So I'll keep it simple and we will take that. Now this,
That, can you rewind it a little bit to the structure of hexene?
No.
Why not?
It would just be a
Because
straight line
I
of 6
am-
lines. And then all the
I
hydrogens.
am busy explaining a situation here that came from a question.
So that's E.
This, sorry, this would have been ethane,
But it's E and that.
but it changed to be a functional group now, so the ethane changes to ethyl.
Yes.
Two
Ethyl. And
Two ethyl
Oh yes.
One
Two ethyl,
One butene.
one butene.
Yes.
Yes, Papa.
Why is it ethyl and not ethene?
because you missed the lesson.
I asked Naima.
When we had this molecule, the side chain has one carbon in it. The side chain, this thing here, has one carbon in it. This thing has one carbon in it. If the organic compound has one carbon in it, what do we call it?
One carbon.
Methyl.
No, it's called methane. It is an individual molecule. The carbon has joined to 4 different hydrogen atoms. If the methane forms a side chain, then the methane changes to methyl. So the ane changes to I.
Is it because it loses the hydrogen?
Yes, it's now a side chain. It's not an independent methane molecule.
I was talking about the name change to
Yes,
H-ion.
yes, because it's a side chain with one carbon join in it. The ethane would have been C, 2 C's with its 6 hydrogens. This is ethane. Ethane, when it becomes a side chain, changes to ethyl. Ethane changes to ethyl when you cut a hydrogen off and you attach it to a carbon chain.
I understand now.
I'm happy now.
Okay.
Just wanted to experiment.
It's fine. It just it just makes it a little bit more challenging. Okay. Did we say we're going to hexenes, isomers?
And after the end of day, you can choose Alkenes.
Yeah, and then we did a portion of the keys and I